Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the complexities of MySQL foreign key constraints and online schema changes. It's a surprisingly thorny issue.
Yeah, I've always wondered about this. Online schema changes sound great in theory, zero downtime migrations, but the reality with foreign keys seems messy.
Messy is an understatement. The core problem stems from how MySQL handles foreign keys. They're not a database-level feature, but rather an InnoDB storage engine implementation. This means they're tied to the table itself, not just the table's name. This is crucial.
So if you rename a table, the foreign key constraints move with it? That's unexpected.
Exactly. And that's where the trouble begins with online schema change tools like pt-online-schema-change, gh-ost, and Vitas. They all use a ghost table approach, creating a copy, modifying it, and then swapping it in. But with foreign keys, you end up with the old table still having its constraints, creating potential issues.
Right, I see. So if you're altering a child table, you create a ghost table with a new constraint name. But the old table remains, and that old constraint can cause problems if you try to delete rows from the parent table, for example.
Precisely. You could drop the old constraint, but that's an alter table operation itself, defeating the purpose of the online schema change. Or you could drop the old table entirely, but that's a risky operation in production, especially for large tables. Even with MySQL 8.023's improvements to drop table performance, it's still a potential point of failure.
So altering a parent table is even worse, right? Because then you have to deal with all the child table's foreign keys.
Oh, absolutely. You're not just altering one table. You're potentially altering every table in the related chain. pt-online-schema-change tries to handle this with its alter foreign keys method rebuild_constraints option, but that only works well if the child tables are small. If they're large, you're back to the problem of needing to perform blocking alter table operations.
And the complexity just explodes with deeply nested relationships. It sounds like a nightmare to coordinate all those migrations and ensure everything stays consistent.
It is. You need to carefully orchestrate the order of operations, handle potential failures gracefully, and ensure you have enough disk space for all those ghost tables. The whole process becomes incredibly fragile, and the risk of data corruption is significantly higher.
So what's the takeaway? Should we just avoid foreign keys altogether?
No, not necessarily. Foreign keys are crucial for data integrity, but this article highlights the significant challenges involved in managing them during online schema changes, especially with large tables. It really underscores the need for careful planning and potentially alternative strategies, like altering replicas instead of the primary.
Interesting. So maybe a more cautious approach with thorough testing and rollback plans is key. And maybe smaller, more manageable tables are a good design choice to mitigate this problem.
Exactly. And remember, the ideal solution would be for MySQL to have truly online, concurrent alter table operations that handle foreign keys gracefully. Until then, we have to work with the tools we have and be aware of their limitations. Thanks for joining us on Tech Bytes and News. We hope you found this discussion insightful. Goodbye.
Bye-bye.